Today you'll be going through chapter 11 of your Redox Chemistry in your 6092 Chemistry syllabus. So over here, there is the success criteria for this chapter, which you can refer to in the syllabus online in the MOE website. Okay, so there are different sections to Redox Chemistry. The first 4 sections is different ways where you can identify whether something is oxidized or reduced. And then section 5 will be identifying redox reaction given a chemical equation. And lastly, you will be seeing how there are different oxidizing agent or reducing agent and how we can utilize them. Okay, so what is a redox reaction? Redox reaction is when a chemical reaction involves reduction and oxidation and it occurs at the same time. Okay, so based on the understanding of the redox reaction and then the application in this cartoon, we can see that reduction and oxidation, they comes in a set. You cannot choose either one. If something is reduced, something must be oxidized in a chemical equation. So always remember, if there is a reduction, there must be an oxidation. It always is in a set. Okay, so examples of redox reaction in real life, we have the process of photosynthesis. So in this photosynthesis is actually the process where plants make food for themselves using sunlight. So carbon dioxide over here, it actually gets reduced. So the reduction of carbon dioxide to form your sugar over here, which is their food, and then your water is actually oxidized to oxygen, the air we breathe in. So you can see it's always a set. Carbon dioxide reduced, water oxidized. It cannot be just carbon dioxide is reduced and then that's it. That's not the end. The redox reaction is always together. Okay, so the other examples is the rusting of your iron and your electroplating. And then over here as an application also, you have your pulse oximeter. So this actually measures the oxygen level in your blood using a redox reaction. So the redox reaction actually shine light beams landing on the blood capillaries, and then from there they determine how much oxygen is in your blood. Okay, so what are redox reaction? As mentioned earlier in the summaries, like of the different sections, we have 4 different ways where we can categorize, or 4 different ways where we can see which substance is oxidized, which substance is reduced. So this is a summary, and the acronym given is actually SHU. So SHU, the S stands for oxidation state, H for hydrogen, O oxygen, and E for electron. So for here, oxidize at the top, you can see there are different plus, minus, plus, minus. So over here in the legend, plus means an increase or a gain. So if you a gain of your gain of your oxygen over here is actually oxidized. So if a substance gain oxygen, they are actually oxidized. But if the substance they lose electron or they lose hydrogen, they are also oxidized. Then the last one is if there is a gain in your oxidation state. So for me, right, I will try to remember only like maybe oxidized. So you just see the top. And then for reduction, right, so this part over here, reduction, is technically everything opposite from the oxidized. So to use this more efficiently, I would just maybe cover the reduction or cover the oxidized part. So I remember either one. And then just to know that is opposite of each other. So for me, oxidized is easier to remember because oxidized, it sounds similar to oxygen. So it will actually gain oxygen and then gain oxidation state. Then hydrogen and electron will be negative, so it's a loss of hydrogen or electron. And then from there, reduction is just everything is opposite. Okay, so we'll start proper. So based on the acronym just now, we'll do again SHOE, your SHU. So for your oxidation, can you try and remember? So oxidation sounds like oxygen, right? So you gain oxygen and there's an increase in the oxidation state. And then the other two will be lose hydrogen and lose electron. So over here, you gain oxygen in a substance is oxidized when it gains oxygen. So it will be reduced when it loses hydrogen. When it loses oxygen. So over here is minus. This is your reduction. So the same for hydrogen. If a substance is oxidized, it loses hydrogen over here. It's the opposite. So it will gain hydrogen. So loses electron, it will gain electron. Increase in oxidation state, it will decrease in oxidation state for when the substance is reduced. So like I said earlier, just remember one part, and then everything is just the opposite. So now we will start with the section 1, gain or loss of oxygen. In the first redox reaction that we are studying is the reaction of magnesium with steam. So magnesium reacts with water in its gaseous state, which is steam, to form magnesium oxide. So over here, we focus on magnesium first. Magnesium in a product, there is no oxygen, and magnesium as the reactant, there is no oxygen. Magnesium oxide as the product, there is oxygen. So it's very obvious here. Magnesium gains oxygen to form magnesium oxide. So gaining of oxygen we already established earlier is actually oxidation. So this is oxidation. So magnesium is oxidized to magnesium oxide. So gain oxygen is oxidation and it's oxidized. So now we move on to the second reactant in this reaction, which is your water over here. So water, it eventually forms your hydrogen gas. So you can see also very obvious, it loses its oxygen to form hydrogen gas. So there is a loss of oxygen. Since there is a loss of oxygen, it is reduced. So water is reduced. Lost oxygen to form hydrogen gas, then water is reduced. Okay, so over here, losing of oxygen to form hydrogen gas is reduction. And then for your magnesium, it gains oxygen to form magnesium oxide and is oxidation. So you see there is a set. Oxidation, reduction. It's always together. That's why it's a redox reaction. Okay, so this last sentence here, water is the oxidizing agent and magnesium is the reducing agent. So what exactly is oxidizing agent or reducing agent? So if something is an oxidizing agent, it wants to oxidize something else. Wants to oxidize so if it oxidizes something else, right, and it's in a redox reaction, it will be the opposite. So itself will be reduced. Okay, so this is oxidizing agent. Itself will be reduced. So we established earlier that H2O, which your water, is reduced. So H2O is the oxidizing agent. So similarly for reducing agent, it wants to reduce something else. And since it's reducing something else, itself will be oxidized. And then we see from earlier, magnesium is oxidized. So magnesium is the reducing agent. Okay. So far, we've already understood what is oxidizing agent and what is reducing agent. Okay, then we'll move on to the second redox reaction, which is the extraction of ion from iron ore. So iron 3 oxide reacts with carbon monoxide to form iron and then carbon dioxide. So we will focus on your carbon monoxide first. Carbon monoxide, there's 1 oxygen. Carbon dioxide, 2 oxygen. So this is a gain of oxygen. If it's a gain of oxygen, this is an oxidation reaction. Okay, so how about your iron oxide? So your iron oxide over here, it loses oxygen. Yeah. It loses oxygen, and hence it's a reduction reaction. So over here, we can say your carbon monoxide is oxidized. Your iron 3 oxide is reduced. Okay. Okay, so reinforcing it again. Carbon monoxide gains oxygen to form your carbon dioxide, so it's oxidation reaction. Your Fe2O3, it loses oxygen to form your Fe. It loses oxygen, so it's a reduction reaction. So your carbon monoxide is oxidized, and then your Fe2O3 is reduced. So try and establish which is the oxidizing agent and which is the reducing agent. So to recall again, oxidizing agent itself is reduced. So who is reduced here in this reaction? Which reactant is reduced? Your Fe2O3 is reduced, right? So your Fe2O3 is your oxidizing agent. So for your reducing agent, itself is oxidized. So who is oxidized in this reaction? Carbon monoxide. So your carbon monoxide is the reducing agent. Okay, so those two are the examples where we will have for the very first part, oxidation and reduction as a gain or loss of oxygen. Now we are moving on to study when it's gaining or losing hydrogen. So the concept is rather similar, but now remember, gain or loss of hydrogen. So remember your acronym over here. SHOE, your SHU. So oxidation, we know is a gain of oxygen. Try and recall, oxidation is a loss of your hydrogen if it's oxidized. Okay, so if it's oxidation, you loses hydrogen. If it's reduction, it gains hydrogen. Okay, so studying the gain or loss of hydrogen in redox reaction, we have your hydrogen sulfide reacting with chloride to form sulfur and hydrogen HCl. Okay, so your hydrogen sulfide to form sulfur, it loses hydrogen. So recall, losing hydrogen this reaction is called oxidation. Gaining hydrogen this is reduction. So your hydrogen sulfide, it loses hydrogen to form sulfur. So this is oxidation. How about your chlorine, your Cl2? It forms HCl over here in the product, right? There is a gain in your hydrogen. Gain of hydrogen. So this is a reduction reaction. If this is a reduction reaction, it means that Cl2 is reduced. Over here, your H2S, hydrogen sulfide, is in the oxidation reaction, so it's oxidized. H2S is oxidized. So which is the oxidizing agent, which is the reducing agent? So recall again, oxidizing agent itself is reduced. Reducing agent itself is oxidized. So from here we determine who is reduced. Chlorine is reduced, so chlorine is the oxidizing agent. Then H2S is oxidized, so H2S is the reducing agent. Okay, so it's actually the explanation is here also. We'll move on to the next reaction. Ammonia and chlorine. So I'll pause here for a while, give you a few seconds, try and determine, or you can pause this video here, and then you attempt to see which one is the oxidizing agent, which one is the reducing agent, who is oxidized, who is reduced. Okay, so I'll write here, who is oxidized, who is reduced. Okay, and then from here, we determine your oxidizing agent and reducing agent. Okay, so pause your video here and give yourself time to try and identify these three questions here from this equation. Okay, so I'll assume that you have already attempted. We'll attempt this question together. So from the first part, we look at ammonia gas. NH3, it forms nitrogen in your product. So it's obvious there is a loss of hydrogen. Losing hydrogen means it's an oxidation reaction. So NH3 is oxidized. So for your chlorine, your product is HCl, there is a gain of hydrogen. So this is a reduction reaction. Which means your chlorine is reduced. So now you already answered the first two questions that I posed earlier. So who is oxidized? So this one question, the answer. Ammonia is oxidized. Then who is reduced? Chlorine is reduced. So the third one, determine your oxidizing agent and your reducing agent. So if something is oxidized, it means that itself is the reducing agent. So this one, reducing agent. Ammonia is a reducing agent. Then your chlorine gas over here will be your oxidizing agent. Okay, so far, do we understand all this part here? So to determine who your oxidizing agent is and who your reducing agent is, right, you have to first find out who is oxidized, who is reduced first. And then from there you work backwards to see who the agents are. Okay. Oxidizing agent. So this two is the answer to question 3 that I posed earlier over here. Question 3. Okay, so now we've already covered two ways which you can deduce which is an oxidation reaction, which is a reduction reaction. So a gain of oxygen over here is oxidation reaction. Loss of oxygen is a reduction reaction. So for hydrogen, it's the opposite. If you gain hydrogen, it will be an oxidation reaction. no, sorry. If you gain hydrogen, it will be a reduction reaction. If you lose hydrogen, it will be an oxidation reaction. Now, we'll move on the gain or loss of electron. So as a recap, you should already know what is oxidized and reduced in terms of oxygen and hydrogen. So for electron, if you loses electron, is the oxidation. So you lose electron. Then for reduction, you gain electron. So over here, you gain your electron. For oxidation state, we will go through this in physical lesson. So we'll talk about electron first. Okay, so over here, we will study this redox reaction in terms of the gain or loss of electron. So if I have copper 2 plus ion reacting with zinc to give you copper plus zinc ion. So we focus on copper first to determine in terms of gain or loss of electron. So to determine this, we have to write out the partial equation first. So what is partial equation? Over here, we focus on just copper. So we just put copper, give you copper ion, gives you copper. So over here, copper has a charge of 0 on the right hand side. And then your copper ion over here has a charge of +2 on the left hand side. The ultimate goal is to make both sides balance out to have a 0 charge. Okay, so 0 charge on both sides. So what do we need to do on the left hand side of the equation to make it 0 charge? We add 2 electrons here. So you have -2. It will balance out to be 0 charge. Okay, so this is for your copper. How about for your zinc? So zinc over here, we focus on zinc itself, give you zinc ion. So on the left hand side in this case now is a 0 charge. On your right hand side is a +2 charge. So again, to balance it to be 0 charge on both sides, we will add 2 electrons on the right. So over here, you focus on the copper. If you have electron on the left, your copper 2 ion is actually gaining electron. So they gain the electron to become like a 0 charge copper. Then over here, your zinc actually loses electron. It loses its electron to become a zinc 2 plus ion. So on the left is a gain of electron. On the right is a lose of electron, depending on where your electrons is on. Okay, so recall again, if it's oxidation, what is it as an electron? Do you gain or lose electron? And then for reduction, is it a gain or a loss of electron? Okay, so for reduction, we lose electron. For oxidation, we lose electron. For reduction, we gain electron. Yeah. So over here for copper, does copper gain or lose electron? Based on your half equation. So this one here. This half equation. Does your copper gain or lose electron? It gains electron, right? So your copper 2 plus actually gets reduced. For your zinc over here, this part, it loses electron, so it's oxidized. Okay, so it's the same. Your copper is 0 charge, and your zinc is 0 charge. So you add 2 electrons for your copper 2 ion to become copper, and therefore your copper 2 ion is reduced because it gains electron. For your zinc, it loses 2 electrons. Sorry, my equation is blocking it. So it actually loses electron to form your zinc 2 plus ion. So it's oxidized because it loses 2 electrons. Okay, so over here, try and determine who is the oxidizing agent and who is the reducing agent. So I'll give you 30 seconds to pause this video and you figure out which one is the oxidizing agent, which one is the reducing agent. Okay, so after you have think, we come back. So what is your oxidizing agent? Something that gets reduced. Okay, so oxidizing agent is something that get reduced. So your copper 2 plus over here gets reduced. That's why your copper 2 plus is the oxidizing agent. And your zinc is the reducing agent. Okay, so we move on to the next example. Hydrochloric acid plus iron to give you H2, hydrogen gas, and iron chloride. So we will determine based on the gain or loss of electron. Okay, so over here we focus on your H, hydrogen, and your iron here. So we write out, first step, write out the partial equation first. So on your left hand side for hydrogen, you have 2H plus to give you H2 gas. So on here you have a plus 2 charge, on here you have a 0 charge. So to balance out the charges to be 0, you add 2 electrons here. Okay, so your hydrogen gain electron. Okay, then the partial equation for your iron. Iron to give you, so over here your chloride always has a -1 charge. Since there's 2 of it, your iron will be +2. So it'll be Fe2 plus. So over here your iron is a 0 charge on the left hand side. On the right hand side your ion has a +2 charge. So again, to balance it, you add 2 electron on the right hand side. Okay. So over here your iron actually loses electron. Let me see, where do I write? It loses electron. Okay, so gaining of electron is reduced. Losing of electron is oxidized. So, okay, repeat again. Your hydrogen is +1 charge. Hydrogen gas is 0. So you add 2 electrons. So remember your 2 over here. Your balancing of the equation. So you add 2 electrons instead of just 1 electron. Therefore, your hydrogen ion gain 2 electrons to form your hydrogen gas, and then your H plus is reduced. Okay, for your iron and your iron 2 plus, it loses electron to gain a charge of +2. Okay. And then your iron is oxidized. So over here, we should be very familiar who is your oxidizing agent and who is your reducing agent. Okay, so your hydrogen is your HCl. Your hydrogen is part of your hydrochloric acid. So HCl is the oxidizing agent, and your iron is the reducing agent. Okay, so the last reaction for the gain or loss of electron. So pause this video here, figure out everything yourself first, and then I'll go through. In terms of gain or loss of electron, which of the reactant is getting reduced, which of the reactant is getting oxidized. Okay, so pause here, take as much time as you need, and then we'll go through this together. Okay, so I assume you have paused the video and came back with the answers in your hand. So we'll start here. In the case that you see this kind of ways, like you have multiple chemical formula inside, you can just break up everything first. So you have your Cu plus 2Ag plus NO3 2 minus to give you Cu2 plus NO3 minus unit 2 plus 2Ag. So over here you see what is the repeated. So NO3 2 minus is repeated, you just cancel it off, you just ignore it first. So you left with your copper and your silver to focus on. Okay, so we'll focus on copper first. For copper, Cu, it eventually gives you Cu2 plus. So it gives you Cu2 plus. Cu2 plus, and then you balance the charge. You need to add 2 electrons on the right hand side to balance the charge. Okay, so this one is a loss of electron. Okay, lose electron. Then the next one we focus on is your silver. You have 2 silver, G plus, to give you 2 silver ions on the left to give you 2 silver solid. Okay, so the left, you need to add 2 more electrons to balance the charge to give you your silver on the right. So this one over here, the half equation, the partial equation, is a gain of electron. Okay, so from here we can determine your copper gets oxidized because it loses electron, and your silver, it's reduced because it gains electron. Okay, so it's the same thing as I went through. And to determine your oxidizing agent and reducing agent, this is very familiar to you already. Your Ag and silver nitrate will be your oxidizing agent because your silver is reduced over here, so it's the oxidizing agent, itself get reduced. Then your copper is the reducing agent, so itself get oxidized. Okay, so this actually sums up our redox reaction based on your gain or loss of electron, gain or loss of hydrogen, and gain or loss of oxygen. So there are the 3 ways you can determine whether a reaction is considered a redox reaction. Okay, so next lesson back in class, we'll go through oxidation and reduction in terms of change in oxidation state. And then this one will be the bulk of this chapter.